Hi and welcome to Linear Equations video 2. In part 2 you're going to be looking at linear equations and basically resolving the four operations appropriately. So the four operations are addition, subtraction, multiplication and division. In this video you will be looking at the four operations and how they are applied to linear equations, and you'll be building an understanding of how to solve equations as an unwrapping of these four operations. I'll show you a range of examples and I'll probably do them quite quickly, so I'll just remind you that this is a video format. You're more than welcome to stop, pause, rewind, slow things down and really get as much as you need out of it. I'll also remind you in this video that as a bit of a prerequisite, I'll be expecting you to be able to expand brackets and simplify simple sets of terms, algebraic terms, and I'll also be expecting you to use the order of operations correctly. So you might recall that the order of operations is usually can look like this: BODMAS, or some variation of that, as our mnemonic to help us remember the order they go in. So we do brackets and we do powers first, and then we do division and multiplication equals second, and we do addition and subtraction equal third. We have to do things in those orders unless there are brackets indicating to do it in a different order. So let's move on to the examples. Now I've talked about this like unwrapping a present. So here's example number 1. 2x minus 7 is equal to 11. Now in the last video you'll recall that we talked about trying to get the term with the unknown in it on a side by itself as our first point of call. So I'm going to try and get the 2x by itself, and to do that I'll need to add 7 to both sides. And what this will do is it will give me 2x minus 7 plus 7 equals 11 plus 7. Now the important feature here is that the minus 7 and the plus 7 cancel out. I did an opposite operation and it caused the cancelling out of two terms. So I had minus 7, I added 7 to cancel them out. The opposite operations, of course, plus and subtract, or multiply and divide. So if you need to remove a multiplied term, then you divide by that term. So my new line of working is 2x equals 18, and I've got 2 times x, so now I divide by 2, which gives me x is equal to 9. And you can see that I've gotten a little bit simpler with my working and haven't done the divide by 2 on both sides. I'm going to start working along those lines as we move through. Example number 2. I'll go a little bit quicker again, and I'll keep on doing that, but slow the video down as you need to. 5x plus 4 is equal to 12. So I want to get the 5x by itself first, so I'm going to subtract 4 from both sides. This will of course give me 5x here, because that 4 will cancel out, and equals 8. 12 minus 4 is equal to 8. Now I'm going to divide by 5, because it's 5 times x, and to remove a multiplication I divide, and I do that on both sides, which gives me x, and 8 divided by 5 is 8 over 5, which is also equal to 1 3/5, or is also equal to 1.6. Any of those three answers are appropriate here, and it really depends on the question. Number 3. X divided by 3 minus 2 is equal to 1. So now I'm going to, first of all, get the x term by itself by adding 2 to both sides. And that gives me x divided by 3, because this subtract 2 is cancelled out, is equal to 3. And now I have x divided by 3, and to get that term by itself I need to remove the 3 by doing the opposite operation, which is multiply by 3. And I have x is equal to 9. Example number 4. 2x minus 6 is equal to 3x plus 4. In this case I have two x terms, two terms that have the pronumeral x. And I want to simplify this by making them into one term. Now, there are two ways we can do this, and I'm going to write this down over on the side with orange. I could either subtract 3x from both sides, which will cancel this 3x out, leaving only x's on this side of the equation, or I can subtract 2x from both sides, which will cancel the 2x out here, leaving only x's on this side of the equation. Both of those methods will work, and you'll find that you may be working with somebody who does it different to you. You should still get the same answer in the long run. I'm going to make the pink choice though, and I'll show you why. By making the pink choice, I end up with 2x minus 2x minus 6 equals 3x minus 2x plus 4, and of course the 2x's cancel out here, leaving me minus 6 is equal to 3 minus 2 is 1, x plus 4. Note over here that 1x just equals x. We don't put the 1 in the front for 1x. And what I've done by subtracting the 2x is I've left my x terms positive. And that's just going to avoid any issues later on. I prefer to leave my x terms positive. But again, you could do it the other way. You'll just end up with some negative terms and you'll need to deal with those. Now I've got this x here. So I have negative 6 equals x plus 4. And I'm going to remove the 4 by subtracting 4 from both sides, leaving me with negative 6 minus 4 equals just x. And of course that means that x is equal to negative 10. And I'm relying on your understanding and ability to work with negative numbers in this question as well. Question 5. 7x plus 1 equals 21. Now I've chosen this example for a very particular reason. First and foremost, I just want to tell you this. If you have an equation with brackets, the easiest thing to do is to expand the brackets. So I'll show you the solution with expanding brackets. So to expand the brackets here, I have 7 times x and 7 times 1. So this is the distributive law. 7 times x is 7x, plus 7 times 1 is 7, equals 21. A lot of people fall for the trap of writing 7x plus 1. But remember that 7 is multiplying everything inside the brackets. Now we go back to our normal method. We subtract 7 from both sides to give us 7x equals 14. And we divide by 7, and that gives us x is equal to 2. We're all very happy with that. It was pretty easy to do. It didn't take that many lines of working, so there's no major issues here. But here's a little side note. You could do it like this. 7x plus 1 equals 21. This means 7 times x plus 1 equals 21. And we can deal with 7 times x plus 1 equals 21 by dividing by 7 first of all. And that gives us x plus 1 is equal to 3. So we've cancelled that 7 out, and 21 divided by 7 is 3. And then we can subtract 1 from both sides, giving us x is equal to 2. Now that is much quicker if you can pick that up. It's an option. You don't have to do it. Don't persist with doing it if you're getting the wrong answers, but it is an option that can be used sometimes. No, same answer. So we're happy. And I have one last example for you. Example number 6. And that is 3 times 2x minus 3 is equal to 2 times 5x plus 4. Now I've chosen this example to be a little bit more complex, but I also wanted to make the point that opposite to what I've just said in question 5, whilst you can sometimes do things easier by dividing by those terms in front of the brackets and not expanding, in this case it's just too complex. And dividing both sides by 3 or 2 don't really help our cause at all. So I'm just going to simply expand my brackets. And that gives me 6x minus 9 is equal to 10x plus 8. And whatever equation you get, the first thing you need to do is simplify it into this form, which should just have two terms on each side, the unknown and a constant, and on the other side possibly another unknown and a constant. Now I'm going to simplify this. So I'm going to make the choice myself to subtract 6x on both sides, so the x's remain positive. And by doing this, I will come out with -9, because that will cancel, equals 4x plus 8. 10x minus 6x is of course 4x. And then I can subtract 8 from both sides to get the 4x by itself. And that gives me -9 minus 8 is equal to 4x, which is -17 is equal to 4x. And now of course I divide by 4, which gives me -17 over 4 is equal to x. And of course here you may write x is equal to -17 over 4, an improper fraction, or -4 1/4, a mixed number, or you might write it as -4.25. However you do that will depend on the direction of your teacher and the type of question you're facing. So just before I finish this video, a couple of reminders. First of all, there are always going to be multiple ways of doing these questions. So don't feel bad if you come with a different method to somebody else. In fact, expect it to happen sometimes. The big point here is though, if you're doing the correct way, you will get the same answer as everybody else. Secondly, if you want to check your answer, you can always take that answer, substitute it back into the question and see if it works. Really quick way, particularly in an exam situation, to make sure that you've done the right thing and it works. Thirdly, of course, make sure that you understand it doesn't matter which side x is on here. It can be on that side or this side. An equal sign is interchangeable on both sides, so work towards the positives if you can. It does avoid any issues or concerns with mistakes. All the best, and I'll see you in the next video.